So I must say that this project was financed by Hafen City GmbH, so the development company that is building the neighborhood, and a subsidiary, the Grasbrook, that is the company of the neighborhood that they are building. The neighborhood is called also the Grasbrook. And during the first year, we had a cooperation, as Arnaud just pointed out, with the MIT Media Lab. And now in the second year, we just started a cooperation with the Austrian Institute of Technology for a couple simulation models that I will show you later. So basically what we are doing when we are simulating urban environment and we are studying cities in general, and we are talking about cities, we are approaching them from this perspective that they are not only form and function, and they are not only buildings and streets, but they are also many other things that are not necessarily tangible. So we need to think about cities as these kind of complex systems that are constantly evolving. So they are urban form, they are also urban vitality, but they are also perception and values. And this is what we consider for when we are modeling our district. And sorry, so basically, in this particular case, we are modeling the district of the Grasbrook. And what we wanted to do is to design this district not from the perspective of making some money building new buildings or making space for offices, but from the very center of, from the perspective of the individuals. So the individuals and pedestrians are really in the center through these two different approaches. The first of them is self-expansion connected to the process of urban identity, so that people can be space owners and they feel attached to the places that they are living in, so they feel that they come from this place. And at the same time, through the process of self-awareness constructed by everyday activity, this is also considering space users, so people commuting there, going there to have drinks, to have lunch, and etc. And in the balance between these two is where we found this project that is focusing on pedestrian environment. So basically, this project is trying to address the question how to plan a new district, being the focus of social interaction activities on urban life in general. So this is the area that we are modeling, the district of the Grasbrook. It looks like an island. It's limited by several canals and a river at the north. And it was a competition a couple of years ago, and now they are starting to develop it. So what we did was to simulate that in Gamma, how the buildings and how the street would affect people. So basically, we are considering people as, pedestrian flow as people doing things in a location through the everyday, so through their everyday activities, which from a more technical way of phrasing it is people with their routines and needs and decisions can be modeled on Gamma, doing activities in hosted by places that are the amenities like shops, restaurants, offices that have a specific function, capacity, and availability that can be also coded in Gamma. And everything happens in formal space with their buildings, with their streets, and with their parks that we can use also in Gamma connected to GIS or BIM databases. So when you scale that up to thousands of people doing millions of things, then at the end you have flow that can be parameterized and can be studied. So basically our simulation model is using formal space as an input, the location of amenities that the user can decide, and then the definition of people with their own routines, so that at the end we can output flow and we can measure flow and then compare different scenarios of distribution of amenities or modifications in the formal space and see how that affects the flow, the pedestrian flow. So our model that we built on Gamma is actually 4 models running simultaneously. One of them is focusing on the process of someone going from home to work. Then we have a model that models the lunch break, if they go out to have lunch outside or if they go to a coffee after lunch. And then model 3 models everything that happens after work until they get back home again. And then we have model 4 that is modeling not the everyday, but the exceptional. And that comes because the designers were treating the spatial use locations differently. So we needed to model them differently. This is, for example, museums or hospitals that you don't visit on a daily basis, but they are also part, not of the everyday, but of this exceptional. So all of these 4 models ran simultaneously in the Cityscope environment, which was started by the MIT. Again, we have several simulation models that are connected to each other, and pedestrian flow modeling is a simulation model is one of them. From a user perspective, you have several access points, as for example, a web interface that you can access from the phone or from the computer, but we also have a physical 3D touch table where you can build move buildings around and see what happens in the simulation when you place a building in a certain place. So the project of the Grasbrook had two steps. The first of them was called the Grazio, and was a simple tool for fast response design iterations that was intended to be used by the designers when they had a blank table, a blank piece of design, and they were starting to place the buildings on the streets and then get real-time feedback about how that was working. Now in the second step, when the design is more or less matured and they have their own BIM models with more detail, and now they are starting to place the functions. That stage is called the functional planning. They have some questions that the models can answer or can address, and help them make decisions about where to place these functions and how to modify the street network a little bit. So our model gives them feedback about that. So we are working with several indicators of this pedestrian flow, and we are also working with several indicators that compute the location of the amenities. And on top of that, we have these other simulation modules, such as, for example, sun exposure, wind flow simulation, solar radiation, or stormwater management, which altogether comes to inform the designers and the users of the tool about the areas of high and low values from the perspective of the intangible values attached to the pedestrian flow, such as what streets are more likely to become hotspots of social life, and then also from the side of the physical space and the comfort that is attached to that. So areas of exceptionally high and low performance in terms of wind protection or sun exposure. So you can match these two things and see how much people is going to be affected by which conditions and where. So yeah, our point was to inform the decisions taken by the designers by the use of this tool. For example, one of the questions that they had was whether to place a bridge from the north of the neighborhood of the Grasbrook to the south of the neighborhood of Hafen City that is right next to it. And our models, with all of the possibilities that we simulated, pointed out that we reduce the length of the trips, obviously, if we have the bridge, because it's a faster connection, but then this affects directly the model choice threshold in which people are deciding whether to walk or take a car. So if you have a bridge there, then people are more likely to walk. If you don't have a bridge there, trips are longer, so people are more likely to take the car, which has an impact in the overall traffic flow and carbon emissions. So it's a way of informing people about the decisions that they are taking, the possible consequence that they are probably having. Then when we are visualizing the different inputs that the user have with the different conditions that characterize the pedestrian flow. For example, we have here the decision from the side of the designers whether to have the amenities clustered in one location, all of the restaurants in one location, all of the offices, or to have a mixed distribution. And here, for example, we see that there's a 59% correlation in the temporal entropy. When you have the amenities mixed, you have areas active 24 hours. If you have an area only with restaurants, then people are going to be there only when the restaurants are open, which is quite obvious, but now we can prove it. And these models gave us also the chance to theorize about the principles of pedestrian flow and how the different conditions that characterize the distribution of amenities affect the different conditions that characterize pedestrian flow. As for example, we can see that having different amenity types or having a higher density of amenities or places to socialize and to do leisure affects also the pedestrian density and how much it affects the average duration of trips, average length of trips, or interaction opportunities. So the chances of people to have physical encounters in the same space at the same time. So last minute, I will talk about the accuracy of our models. So I didn't talk about the technicalities of the data, but I can talk about the accuracy. Very quickly. So what we did to test if the assumptions that we were making and the data that we were using was accurate or not was to model with the same conditions the neighboring neighborhood, that is the neighborhood of Hafen City. What happened there in 2019 was that they placed some automatic pedestrian counters in some sidewalks, and they measured the real pedestrian flow by pedestrians in the streets. So we compared our agents walking in that district with the results measured by the cameras counting pedestrians, and we found out that the simulation and the real data were quite similar, with a very similar distribution, with a maximum deviation of around 6% that we were able to cut by half when we added the weight of in the places we weighted them by the attractivity, which that we extracted from social media. So yeah, basically this model helped us theorize about amenities defining flow and flow creating social life, so that basically the designers, by the use of these tools, can make decisions so that cities are more inclusive and better for everyone. That was all. Thank you very much.